In this video, we're going to introduce the concept of a sampling distribution. A sampling distribution is a distribution composed of sample statistics instead of individual data values. And remember that sample statistics are values that we have calculated based on sample data, things like sample means or sample standard deviations. So a sampling distribution is a distribution of things like sample means instead of individual height data. So for example, suppose I'm interested in studying the average height of US high school students in 9th through 12th grade. It would be impossible for me to measure the height of all 17.3 million high school students in terms of time and money. So instead, I'm going to collect samples of size 100. The distribution formed from the sample means from my repeated samples of size 100 is a sampling distribution, specifically of sample means. Statisticians like sample means because they allow us to make inferences about populations without having to interview every member. Sampling distributions are how we are going to move from looking at raw sample data to making statements about the population from which that sample was drawn. We know a little bit from intuition and a little bit about our previous discussions that things that would make my sample study better would be larger samples. Larger samples are always better in statistics. And more samples. One sample of 100 is great. 100 samples of 100 each is better. In our next video, we're going to look at the central limit theorem, which tells us about the sampling distribution as we change these factors, sample size and how many samples we take. We do know some things about the sampling distribution of sample means if we are doing our sampling with replacement. So if I randomly select 100 people, but when I select them, I put the name back in the hat so it could be selected again, then I know two things will be true about my sampling distribution of sample means. The first is that the mean of the sample means will be equal to the population mean. Meaning the mean of the sample means of all of my samples of size 100 should be approximately equal to the population mean height. So I can use these sampling distributions to figure out what my population mean looks like without actually having to interview the whole population. In symbol form, the mean of the sample means will be written as mu with an x bar as a subscript. And that literally means the mean of a distribution of sample means. And we are saying that that is equal to the mean of the original population of raw data. The other thing we know is that the standard deviation of the sample means will be smaller than the standard deviation of the population. Specifically, that it will be equal to the population standard deviation divided by the square root of the sample size. Meaning the larger the size of my sample, the smaller the standard deviation will be, the more clustered those sample means will be about the population mean. And that makes sense in that the larger my sample, the more it accurately reflects the population we pulled it from, the closer its average should be to the population average. So what we would say is that the standard deviation of our sample means is equal to the standard deviation of the population divided by the square root of the sample size. This quantity here, the standard deviation of the sample means, is often called the standard error of the mean. So you may see shorthand SE or SEX bar, and that's standard error, which is a measure of standard deviation specifically for a sampling distribution. All right, if you have any questions about what you saw in this video or anything from week 3, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.